Okay, so we're going to go through some ratio type questions from grade 4 all the way up to grade 7 plus. So start with this one. So it talks about blue, yellow and green. There's twice as many blues as yellows, so we can take some information from that, and it's useful as you get information to kind of jot it down next to the question. So we can see that blue to yellow, twice as many blues as there are yellows, so that'll be a ratio of 2 to 1. And then they're saying there's 4 times as many green cubes as blue cubes, so we can say blue to green, 4 times as many green cubes as there are blue cubes. Okay, so we can see that that's the kind of scenario. Hannah takes a random cube from the bag. Work out the probability that Hannah takes a yellow cube. Okay, so we need to kind of see what's going on about how many of each in terms of the ratio. So we actually need the ratio of blue to yellow to green. So what we can do with this, because there's 3 different quantities involved in this ratio, 3 different variables, we can put them together. So the blue to yellow was that, and the blue to green was that. So we can see that we need the yellow one here to get the ratio of all 3 together. So we can see that we can get a lowest common multiple here of 2. So if we turn everything into 2, then I've got to double that. So I've got to double that. And this one I've already got the same as 2. So we can see all together in this question then we're dealing with fractions where the blue is 2 out of 11. Remember we get the 11 by adding up all the bits here. 8 plus 1 plus 2, that gave us 11. So 8 plus 1 plus 2 is 11. And the yellow was 1/11 and the green was 8/11. So the question says work out the probability that Hannah takes a yellow cube. So we would say the probability of yellow is equal to 1/11. Okay, so just a quick recap. We can see that we can take the information and write some ratios from it because of the way it's been worded, and we can see that this scenario involves 3 different variables, blue, yellow, green. So if we get the connection between all 3 of them by looking for how the ratios compare to each other to make it equivalent. So we look for the lowest common multiple between what we know the blues here, so we make it 2. Then we've doubled that to make that 2, so therefore we must double that to make that 8, and therefore we can work out how many parts we've got all together, and then we can write them as fractions, and probabilities tend to be as fractions. Okay, so that's how that question could be done. Although classically we think of this as an exchange rate question, it is actually a ratio. So we're literally talking about 1 gallon is 3.75 litres, so gallons to litres, we can write that as 1 to 3.785, and so we can talk about the currency being pounds to dollars. One of those is $1.46. It's telling us that in London 1 litre of petrol costs 1.08, so, and in New York a US gallon costs that. So we need to do like for like. So if I've got to turn the US gallons into pounds, or the pounds into US dollars, so if I turn the dollars into pounds, then I know here I'm going to be putting 283, and I want to know what that quantity is there. So I've got to ask myself, how did I turn this into this? Well, I must have times by the division of the 2, so the scale factor. So calculate a job, this one. Not expect to do that in your head. Okay, so this answer here is going to be £1.94. Because this equals 1.938, which is 1.94 to 2 decimal places when we're dealing with money, then I must have multiplied by 1.938, so I must multiply the same this side. So that's got the cost of a US gallon, and basically we want to work out a comparison for the London price in pence, and that's about 1 litre. So what we've got to do now is we've got to think to ourselves, a US gallon is 3.785 litres. So if we want the cost per litre, then we're going to have to do the 194 divided by 3.785. So I left that in my calculator. Quite often, guys, it's useful to leave the last calculation in there. So all I have to do now is press divide 3.785, and that gives us 0.51. So per litre. Remember, it's useful with these kind of questions with units to write down the units as you do it to see what's going on. And that's 51p. So 51p is less than 108, so 108.9 pence. So New York is cheaper. Okay, so that's one way of doing that particular question. Okay, so this question talks about blue pens, green pens and red pens. It's told us the ratio of the number of blue pens to green pens. So we know blue to green is 2 to 5. And then it's telling us the ratio of the number of green pens to the number of red pens. So we've got green to red, which is going to be 4 to 1. And basically, because we're talking about there's less than 100 pens in the box, we know that they're going to be made of these 3 different colours. Then we need to know what the ratio is of all 3 colours together. So the way we do that is when we've got these scenarios where there's 3 different variables, then we make a lowest common multiple, and the lowest common multiple of 5 and 4 is 20. And therefore we're going to turn this ratio into 20 to make equivalent. So we have to multiply that by 5. So we have to multiply that by 5. And to get this 5 to become 20, we have to multiply by 4. So we have to multiply that by 4. So we now know that the ratio of the different colours is 8, 20 and 5. It's saying we want less than 100 pens, so basically we know that the minimum number of pens would have been 8 plus 20 plus 5, which would have been 33, and we know that 3 33s is 99, so if we times up by 3, then keeping it equivalent, so again we're working with this idea of equivalent ratios, then times that by 3, times that by 3, times that by 3, then we can see that this would be a total of 99 pens, so 24 plus 60 plus 15, 84, 94, 99, and that's as close to 100 as you're going to get, keeping the ratio to the equivalents. So again, that's how that question could be done. So when you've got these scenarios where you've got 3 variables going on within a ratio question, then quite often it's about writing the lowest common multiple of the pairs that you can find, so that you can then work out the missing values you need. Okay, so this question talks about a village, and it's telling you that the number of houses to the number of flats are in the ratio of that. So we've got houses to flats. Again, very useful to write down headings as you do these questions so you can see what's going on. So we've done that bit of information. It then says the number of flats to the number of bungalows, so that means we're involving a third variable now. So we've now got flats to bungalows is 8 to 5. And it's saying there are 50 bungalows in the village. How many houses are there? So we need a connection between houses and bungalows. Again, it's one of those questions where we've got 3 variables. So if we find the lowest common multiple, so the lowest common multiple of 4 and 8 is actually 8. So we've got the lowest common multiple of the variable we know 2 things about, and therefore we write down everything else. So we know when there's 8 of those, there's 5 of those. But we know what happens with 4 of those. We want to make 8 of them, so we've got to double it. So that means we've got to double up that one. So 14. So we now know that for every 14 houses there was 5 bungalows. Now the question says there are 50 bungalows, so we can put the 50 underneath the heading for bungalows. That means we must have multiplied by 10 to get that 5 to become 50, because equivalent ratios again is about this idea if you do the same to both sides or the same to all the variables. And so we times by 10 here, so we end up with 140 and 80 there. So the answer to this question would be there are 140 houses, because the question asked you for how many houses. So we've done that, so we've done all the question. Okay, so this next question talks about the perimeter. So again, the UWhat principle, underlined key information. So we know perimeter means add all edge lengths. So we've got to remind ourselves what keywords mean. So perimeter is add all edge lengths, and it's talking about a right angle triangle, so we can help ourselves by sketching out a picture of what was going on. And it's telling us that the right angle triangle has a perimeter of 72, so that means that length, and that length must all add up to 72. But it's telling us that the ratio of the lengths is 3 to 4 to 5. So we know the longest length must be the hypotenuse of the right angle triangle, and then the other two could be either. So we know what that's, the ratio is telling us that the smallest triangle possible for this would have been 3, 4 and 5, but they're telling us it's actually 72. So we've got a couple of ways we can do this. We could recognise that these numbers would add up to 12, and therefore this has got a perimeter of 12, but the question says we want a perimeter of 72. So to make a perimeter of 72, we can times everything by 6. So that would be 18, 24 and 30. And then we do a quick check, 30, 50, 54, 64, 72. So that would work. So we now know the dimensions of our new triangle. So we've got that information from the fact that we could draw out a sketch and see what's going on. We could have decided that each of these represents a fraction, so 3 to 4 to 5, so we could recognise that the length that's equivalent to this side would be 3/12, this would be 4/12, and this would be 5/12, and then we could have done 72 divided by 12, which is 6, and then again we would have multiplied all of those numbers by 6. So, we could have done this in a couple of ways, but I think sketching the picture sometimes helps to see what's going on. Now I need to go back to the question itself, of course, and because it involves a formula, my recommendation is always write out the formula and have a little sketch to remind yourself what you mean by each of the variables. So we know B represents the base length of the right angle triangle and H represents the perpendicular height. Remember though that the triangles could be in any orientation. So that could have been the base length and that could have been the height. It's just made it at right angles to each other. So the area is going to be a half times, well, we can see from the information we calculated that the base length would be 24, and we can see that the perpendicular height would be 18 for this particular triangle. And we do that calculation, a half times 24 is 12, so we end up doing 12 times 18, and we recognise 10 times 18 is 180. 2 times 18 is 36, and then when we add those together we get 216, and we know this question involves units, so we should always be thinking of what the units will be, and because they said in the original question the lengths were all measured in centimetres, then the area must be square centimetres, so that would be the answer to this question, 216 square centimetres. Okay, so we've got a question here that talks about shapes in a game. Some of the shapes are circles and all the other shapes are squares. So we've got circles and squares going on. The ratio of the number of white shapes to the number of black shapes. So we've got white to black is 3 to 7. The ratio of the number of white circles to the number of white squares is 4 to 5. So white circles to white squares is 4 to 5, and the ratio of the number of black circles, so we've got black circles to black squares is 2 to 5. Okay, so that's the information kind of sorted out, and it says work out what fraction of all shapes are circles. Okay, so when we're dealing with two different variables in ratio form, quite often we might think of turning it into fractions to sort of get a feel for what's happening. There's a fixed number of shapes, so we're going to be sharing these shapes out so we can work out the number of white circles and so forth. So of the whole shapes in the whole game, then we know that 3/10 of them are white and 7/10 of them are black. Out of the white ones, we know this ratio, and we know that the white circles, out of all the white ones, there's 4/9 that are circles, and there are 5/9 that are squares. And it's saying what fraction of the shapes are circles, so we've got to be clear that we're dealing with this. So to get the number of white circles, then so number of white circles, well, it must be this fraction of these. Now, because the question said it wants it as a fraction, then we don't actually need to know how many of these shapes there were. We just need to know what fraction was going on. So the number of white circles, well, there must have been 4/9 of the 3/10. And when we think of in mathematics, we tend to be thinking of doing timesing. So we got that. So 12/90. Now when you're timesing fractions, you times the numerators and then you times the denominators, and then that gives you that. And we also then need to know the number of black circles, because the question is talking about the total number of circles. And the blacks, there were 7/10 of all the shapes which were black, and circles was here, so that's 2/7. Remember, to get the fraction we add the two variable parts, 7 parts altogether in this, and therefore we've got 2/7 of them being black circles, and that's going to be 2/7. So we're going to end up doing 7/10 times 2/7, which is going to be 14/70. Okay, so the question said what's the total fraction. So the fraction of circles, well, that must be the two fractions added together, so 12/90 plus 14/70. Now we don't want to make this too complicated, so we want to cancel these down to make them easier to work with, and we can see that 14/70 is the same as a fifth. There is divide that by 14, divide that by 14, and you get a fifth. And we can see that 12/90, well, both of these will divide by 6, so we end up with 2. 6 is into 12 is 2, and 6 is into 90 is 15. So we're going to do 2/15 plus a fifth. Well, we know that a fifth is equivalent to 3/15, because times that by 3, times that by 3. So we've got 2/15 plus 3/15, which equals 5/15, which then cancels down to 1/3. Okay, so that question, that's one approach to get the final correct answer of 1/3. Okay, so this question here talks about points on a line, so always useful to sketch out and help yourself to see what's going on. So we've got the points A, B, C and D, and they're basically saying A to B is represented by 1 and B to D is represented by 5. And they're saying that A to C is represented by 7 and C to D is represented by 11. Okay, so we can see that the question wants you to work out the ratio of AB to BC to CD. Again, what we're looking for is we're looking for connections in terms of how this can be worked, so we need a lowest common multiple going on here. And what we can see is that 7 and 11 add to 18, 1 and 5 add to 6. So if we want to work with common bits, then we know to get 6 to become 18, we times by 3. So basically we're going to be thinking of A to B will be 3 and B to D will be 15. So what we've got to do then is we've got to think about how we're going to write this down then. So we want A to B, B to C, C to D. Right, so A to B is 3. B to C, well, if B to D is 15 and C to D is 11, then we know that B to C must be 15 take away 11, so 4. So, and that's going to be the 11. Okay, so add those up, we get 18. We can check that that was our factor. So with this question then, we worked out that these two had a connection. To get the 6 to become 18, we multiplied by 3. So we turned these into common multiples, so that we were working in 18 across here as well for the A to B and B to D parts, and then we just compare what we've got. So that was the answer to that question. Okay, so this next one now we're getting to slightly grade 7 plus questions, guys. So if you're doing foundation, then these kind of questions are not going to appear on the foundation paper. So we can see here we've been given a ratio and it's equivalent to that. So basically what they're saying is y plus x to y take away x equals k to 1. Now when you've got this scenario, we can write these as fractions. So we can say that y plus x shared by y take away x must be the same as k divided by 1. So basically we're going to have this idea now that we can rewrite this by doing a multiplication. So we're going to take the 1 across there, which will give us y plus x. We're going to take the y take away x over there by multiplying, but it's a two-term expression, so we multiply with it in a bracket. And what we then do is we rearrange this because they want to get y as the subject. So we've got y plus x is equal to ky take away kx because we expand the bracket. We want the y terms together because we need y on its own, so we're going to subtract ky from both sides. So we end up with y take away ky plus x equals negative kx. We then recognise that the x is in the wrong place, so we take away x from both sides, so we end up with y take away ky is equal to negative x take away kx. We know that we want y to be the subject, so we factorise the y out to make it a common factor. So y, if we divide that by y we get 1, and divide that by y we get k. So that equals negative x negative kx. And we look at what they wanted the answer to be. So we know they want to end up with y on its own, so we end up with y equals negative x take away kx over 1 take away k. But what we noticed about the answer is they wanted positive k take 1 on the bottom, not 1 take away k. So the way we do this is we multiply by negative 1 over negative 1. And literally what that does is it just changes all the signs from the negative to positive and positive to negative. So that would then allow this, we'll basically multiply by 1, because negative 1 divided by negative 1 is 1. So we're not going to change the value of this, we're just going to change the way it looks. So that actually gives us, so the opposite of that is going to be x plus kx, and the opposite of this is going to be k take away 1. And again we look at the answer they wanted and we can see that they want the x to be factorised out. So literally we finish off by factorising x out here. So we divide that by x to get 1, divide that by x to get k, and we've got k minus 1 at the bottom. So that's how that question could have been done. Literally about this idea that we could recognise that a ratio, when it's equal to another ratio, they can then be written as fractions, and then we can rearrange and to do the question as it wanted. Okay, so we've got a question here which looks quite complex when you actually read through it. Okay, so it's telling us lots of information. When we subtract and so forth, find the ratio of P to Q. So what we recognise about this question, guys, is if we use the U-What principle, underline really key information. You know, what are the triggers? What's things going on here? Well, we know that we want a ratio. We know this question's talking about two variables, and when a question's talking about two variables, then and we don't know them, we should be saying to ourselves that we're very likely to be creating simultaneous equations. Because we need to know the values of them, because they're saying find the ratio of P to Q, then we know that we're going to create simultaneous equations. So from this information we've got to create some equations. So basically they're saying when you subtract 5 from P, the ratio of that to when you subtract 5 from Q is equal to 5 to 1. So that's what the first bit of information is telling us. That then allows us to write a fraction here, because when we've got an equals, when we've got a ratio equal to another ratio, we can write them as fraction equivalents. So P take away 5 over Q take away 5 must be the same as 5 over 1. And when we rearrange that, 1 times this is P take away 5, Q take away 5 times 5, opposite of dividing is timesing, is equal to 5 brackets Q take away 5. So P take away 5, expand the bracket, and because we know simultaneous equations, it's nicer if the letters are on one side and the number is on the other side. It's just a kind of a process. Then we're just going to swap the 5Q over to the other side by subtracting it. That was positive, so subtract 5Q. We're going to add 5 to make the 5 move across the other side to put the numbers together. So adding 5 makes negative 20. So there's our first equation. So that's kind of equation A. We've been given a second sentence, so we can then work out a ratio for that, because we've got P plus 20 in ratio to Q plus 20 is equal to the ratio 5 to 2. Well, we're going to follow the same process as before. We're going to say that P plus 20 over Q plus 20 must equal 5 over 2. That's going to then allow us to times by 2 times by 5 and expand the brackets. And again, just like before, we want to have the letter terms on one side and the numbers on the other side. So we're going to take away 5Q and we're going to take away 40, the opposite of adding 40. So we now have got our two simultaneous equations. Okay, so now that we know this is about simultaneous equations, we do our standard approach to solving simultaneous equations. So we write our equations out. So we've got P take away 5Q equals negative 20. We've got 2P take away take away 5Q equals 60. And what we want to do when we solve simultaneous equations is we want to have something the same. So either the number of P's the same or the number of Q's the same. Well, we can see here already we've got the number of Q's the same. So okay, so we can subtract these two equations. So P take away 2P is going to give me negative P, and negative 5Q take away negative 5Q means I add the 5Q's to make 0. Negative 20 take away 60 is going to be negative 80, So we know that negative p equals negative 80, then p must be 80. And once we know that p is 80, then literally we just put that into one of the equations. So 80 take away 5q is negative 20. So negative 5q must equal negative 100. So q must be 80. Nope. Sorry, divide, isn't it? So we're going to divide by negative 5, which is going to be 20. Yeah, so q is 20. So we've now found that p to q is 80 to 20, and it says it wants it in its simplest form, so we must remember we've got to write this in its simplest form. So we end up dividing by 20, so we end up with 4 to 1. So the answer to this question then is 4 to 1. Okay, so let's do a quick check. Did these numbers work, 80 and 20? So if we put p is 80, so 80 take away 5, yep, so if we do a quick check here, so 80 take away 5 and q was 20, and 20 take away 5 is, so 20 take away 5, that gives me 75 over 15, which is 5, and we know the ratio was 5, so our check worked. Again, when you do all this hard work, a 5-mark question, it's worth going through and checking that what happened actually does work for the scenario they gave you. So quite a complex question, but just a couple of key ideas really. Just remembering that if you've got a ratio equal to a ratio, you can write it as a fraction, and then it's about your rearranging skills, guys, and creating your simultaneous equations to then solve them. Okay, so we've got a question here that talks about shapes being similar. So again, key information, it's about similar shapes, so we should be thinking about linear scale factors. The area scale factor is equal to the linear scale factor squared, and the volume scale factor is equal to the linear scale factor cubed. They're talking about the surface area, so therefore we can get a area scale factor. So from that information there, we can get that the area scale factor was 25 over 4, so 25 quarters. And it's telling us that the ratio of the volume of shape B to shape C is 27 to 64. So if we've got the ratio of the volume, then we know that that is telling us, let's get the question context. Yep, so this is telling us that for shape B, we know that the linear scale factor is the cube root, because if the volume scale factor is equal to the linear scale factor cubed, then we're basically going to cube root these. So for B to C, so the ratio of the volume of B to C is 27 to 64. Then for the linear scale factor, we cube root both of those, so we end up with 3 to 4. So the area scale factor of A to B was 25 to 4, so the linear scale factor will be the square root of those. So this was B to A, so we square root those, 5 to 5 to 2. So A to B is 2 to 5. Okay, so square rooting those gave us those, and cube rooting those gave us those. So we now know that A to B, because it's talking about height, then we know that means it's about the linear scale factor. Then A to B, we've got us 2 to 5. B to C, we've got us 3 to 4. And what we should recognise is that we've got 3 variable ratio going on, so we've got to get a lowest common multiple, so 15, and to turn 3 into 15 I had to multiply by 5, and to turn 5 into 15 I had to multiply by 3. So this tells me that that's going to be 6 and that's going to be 20. So it says work out the ratio of the height of A to C. So the question wanted A to C, well it's 6 to 20, but it wants it in the simplest form. So we know we're going to divide that by 2, and we're going to divide that by 2, and so the answer to this question is 3 to 10. Okay, so the way this question worked then is you looked at the key information. They told you it was about shapes that were similar, so we should be thinking about scale factors when we talk about similar shapes in 3D. And they told us this information about A and B, which allowed us to work out the area scale factor. But because the question talked about the height, it means we wanted to work out the linear scale factors. So if we reverse these, the square root of the area scale factor will give us the linear scale factor, and that's why we ended up with these numbers here. And we cube rooted the volume scale factors, and that gave us the ratios. And then of course we looked at our technique of when we've got three variables, look for a lowest common multiple to get what the ratio will be for all three parts together, or all three quantities together. Okay, so that's how that question could have been done, guys. Okay, so again we've got a question here talks about two cones mathematically similar. So again we should be thinking about linear scale factors, area scale factor equal to the linear scale factor squared, and the volume scale factor is equal to the linear scale factor cubed. So we recognise that those are the facts, and it tells us some information. It says the ratio of the volume of A to B is 27 to that, and it says the surface area. We've got to show that the surface area of cone B is 132. Okay, so we need a connection between the volume scale factor to give us the linear scale factor to then give us the area scale factor. Okay, so we know that the volume scale factor is the linear scale factor cubed. So the linear scale factor cubed must be the cube root. So the linear scale factor is equal to the cubed root of the volume scale factor. Well, they've told us what the volume scale factor is. It's 27 to 8. So if we cube root all of those, then it tells us that A to B, in terms of the linear scale factor, is going to be, well, the cube root of 27 is 3, and the cube root of 8 is 2. The question then wants to do the area. So we need the area factors. So to get the area scale factor, it's the linear scale factor squared. So for the area scale factor, it's going to be, for every 9 of A, we square that, it's going to be 4 on B, on area. Okay, so now we can put in the information we know. So we know that A is equal to 297 square centimetres. So that means we can put the A number there. And then we're saying to ourselves, well, 9 must have turned into that, so therefore we must have multiplied by 33. 9 30s is 270, 9 3s are 27, yeah, that works. And then we multiply that by 33, so that gives us 120, 132. So B equals 132 square centimetres. Alright, that's what the question wanted. It wanted us to show that the surface area of B is 132, and using the key information in the question that we're talking about mathematically similar shapes, we know there's a connection between the scale factors then for all the lengths, areas and volumes, and then we just work through how to use the ratio to help us get those. Okay, so that's a run through of lots of area questions and volume questions and ratio questions in general, and the different types of the different grades from grade 4 up to grade 7+.